Assalamualaikum and hi. My name is Umi Najwa binti Abu Hanifah and this is my partner Nur Shafinas binti Idris. In this video, we will present to you about our project assignment regarding heating, ventilating and air conditioning technology. The term HVAC refers to the many systems used for heating, cooling and transporting air between interior and outdoor spaces in both residential and commercial structures. It is the device that maintains comfortable humidity levels and clean indoor air to keep you healthy. And HVAC systems serve purposes other than only heating or cooling a space. It also helps to enhance the comfort of everyone in a facility and improve indoor air quality. A residential HVAC unit functions similarly to an industrial HVAC system, but on a much bigger scale and with more intricate components. There are four major components of an air conditioning system. They are the evaporator, condenser, compressor and expansion valve. The refrigerant is compressed in the compressor and turned into a hot high-pressure liquid. This liquid flows toward the condenser coils and is cooled down with the help of a large fan. Next comes the expansion valve, which rapidly expands the refrigerant, converting it into a cooled low-pressure gas. This cool gas is what cools down your room. That is done in the evaporator coils. The coils get cold and a fan in the indoor unit blows the warm indoor air over them, turning down the temperature. According to Daegu 2014, the first thing that probably comes to mind when constructing a heating, ventilation and air conditioning HVAC system is to choose a system that is large enough to always maintain the interior environment at the required condition even in the worst weather circumstance. Meanwhile, according to Hernandez and few more 2020, the heating, ventilation and air conditioning HVAC sector has made significant progress in recent decades in terms of performance and efficiency. This momentum has been sparked by the development of variable refrigerant flow (VRF) systems, which are starting to displace conventional HVAC systems in both residential and commercial applications. Since the cycle in this system, which are dual-mode heat pumps, may be turned around to give heating, just one system can do, either cooling or heating. According to Solano ETAL 2021, air that is clean and within particular acceptable comfort range in terms of temperature, humidity and air movement is referred to as conditioned air. The main objective of a building HVAC system is to make the inhabitant feel comfortable so that they may be more productive, happier and healthier. Additionally, it may provide a cozy inside space for both building occupants and their equipment.
The location of building is located at Kota Sas, Bandar Baru, Kuantan. This research will focus on house in that location since the Kota Sas is in housing area. There are mostly social activity usually take place such as gathering. Renovation of the house sometimes take place according to the owner's need.
This is the layout of the building. This layout was colored in different colors to differentiate the bedroom, toilet, kitchen, living room and garage. The size for this building is 60 meter high and 30 meter long. The selected places consist of 2 rooms with one of it used ceiling cassette air conditioner, 2 toilets with ventilation fans, 2 rooms with windows, a living room with a ceiling cassette air conditioner, a kitchen with ventilation fan and a garage. The types of the windows used in this building are window glazing, as this building uses cassette ceiling air conditioner, which it must keep cool air inside while maintaining a comfortable temperature. The wind speed in this building is quite high, as this building can get natural wind easily.
Next, I will explaining about the thermal comfort. Thermal comfort is a condition of mind that expresses certification between the thermal environment. Due to its subjectivity, thermal comfort is different from every individual. This factor may be independent of each other but together contribute to the occupant thermal comfort. For example, air temperature, radiant temperature, air velocity, humidity, and for the personal factor is clothing and metabolic heat. For this study, we are focusing about three factors for temperature, cloth, and occupant. For the temperature, thermal radiation is a heat that radiates from a warm object. Radiant heat may be present if there are heat source in an environment. Radiant temperature also play a great influence than the air temperature on how we lose or gain heat to the environment. Example of radiant heat such as the heat, the sun, fire, electric fire, machinery, and molten metal. The temperature of the air surrounding also played a big role in the thermal comfort. So in this study, the assumption for the temperature outside is 33 degrees C and the temperature inside house is 21 degrees C. As we know, air conditioning is provided and the temperature inside of house will be cooler than the outside temperature. For this study, the maximum number of the occupant in the house is 2%. People have different metabolic rate that can fluctuate due to activity level and environmental condition. In fact, the more physical work we do, the more heat we produce, and the more heat we need to be lost to avoid overheating. The impact of metabolic rate on the thermal is critical. Other than that, when it comes to the thermal comfort, a person's physical attribute should always be considered. For the clothes, thermal comfort is much dependent on the insulating effect on clothing on the wearer. Wearing too much clothing may be a primary cause of the heat stress even if the environment is not considered warm or hot. If clothing does not need enough insulation, the wearer may be at risk from the cold injuries such as frostbite or hypothermia in a cold condition. Clothing is both a potential cause of thermal discomfort as well as a control for it as to adapt to the climate in the household.
This is the air conditioning layout for the building HVAC system.
Next, I will be explaining about the energy usage for HVAC system, which included the air conditioning layout, type of the air condition, passive cooling, heat loss, and gain, the component and the contribution of the heat load, and the assumption in internal cooling load. The type of air conditioner used inside the house is a ceiling cassette air conditioner. The ceiling cassette is one of the type of ductless mini split system, where the indoor air handler is not installed on the wall or floor, but instead it will install in the ceiling where the rest of the components are hidden away behind the ceiling. So based on the ceiling cassette used inside the house, the capacity is 1 horsepower and the energy efficiency rating for model from Daikin is 2.93. So the higher the rating, the more efficient the aircon unit is. Passive cooling uses a free renewable source of energy such as the sun, wind, and to provide cooling, ventilation, and lighting needs for the household. This additionally remove the need to use mechanical cooling. Applying passive cooling means reducing difference between outdoor and indoor temperature, and it also improving the indoor air quality, and it will make the building more better for the and more comfortable environment to live and to work in. And it also reduces level of energy use and the environmental impact such as a greenhouse gas emission. Wind does not actually blow through the building. It is sucked to the area of the lower pressure. To draw the breeze through the house, use larger opening area on the low pressure side of the house and the smaller opening area on the high pressure side. Opening near the center of the high pressure zone are more effective than the opening on the edge because pressure is the highest near the center of the wind wall and diminish toward the edge as the wind finds other way to move around the building. Breeze can be deflected or diverted, so perfect orientation to breeze direction is less important than the actual design of the window and opening to collect the direct breeze within and through the home. Windows are the main element in the transfer of the huge amount of heat between a building and the exterior environment. Next, I will be explaining about the component and contribution of the heat loss. So, according to this table, the cooling loads components such as conduction through the roof wall window, solar radiation and conduction through the ceiling interior does not affect the lantern load, while system gain heat also does not affect by the lantern hood and the space load. This is the summary of the internal cooling load. So as we can see, the component in the internal cooling load is the occupant, which is 2%, and the light, about 10 lamps, and the equipment in the house. So the total of the accessible heat load is the 1870, and the latent heat load is the 90 watt. For the summary of the external cooling load is conduction through the wall, window and the roof. And the accessible heat load, the total for the three conduction is around 9340 and 66 watt. Next is the strategy or any technologies to improve the energy sustainability via heating, ventilation and air conditioning. So instead of having the air conditioner run on the high during the warmer season, the programmable thermostat can run at the constant level, and the vice versa with the colder season. This prevents major hot and cold spots in the different area of the home. So next is the demand control ventilation. Demand control ventilation or DVC means that the building automation system adjusts and minimize the supply of the outside air according to the effective requirement within the aim of the optimizing both room air quality and energy efficiency. DVC also save energy by minimizing the amount of the required for the driving the fans and for the treating the supplied fresh air, such as cooling, heat dehumidifying, and heating. As for the conclusion, the aim of the study to observe the usage of the hatchback system toward the thermal comfort in combination between two design houses is achieved. The results show the energy usage of hatchback system toward the thermal comfort, which affected by the factors such as the occupant, clothes, passive cooling, heat gain and loss in the room, and the internal and external cooling load. So to conclude, the thermal comfort is linked to the hatchback system, and the energy used can be saved by using various strategy or technology to lessen the energy consumption without ignoring the thermal comfort.